Happy Friday, everybody, and welcome to today's webinar. We've been involved recently with several incidents and claims involving lithium-ion batteries. I asked Russell Simmons if he would please give us a 10-minute tutorial on what exactly lithium-ion batteries are, and then and why we may be seeing so many issues with them, and then spend the next 5 or 10 minutes after that discussing specific cases involving lithium-ion batteries that he's been involved with. Russell's the perfect person to educating us this afternoon. After graduating from North Carolina State with an electrical engineering degree, Russell worked the next 30+ years at JEA. JEA is the Jacksonville Electric Authority, which is the public utility in Jacksonville and Northeast Florida. At JEA, Russell was involved in all aspects of electricity, power distribution, transmission lines, and battery technology. For the last over 6 years, Russell's not been with us at CD, where he's investigated all manners of fires, explosions, electrocutions, and shocking events, everything from pool electrocutions to faulty lamps that have burned down houses or hotel rooms. We're going to try to be respectful of the 20-minute time frame we've set for today. So if you have any questions, please type them in, and we'll try to address them at the end of the presentation. And as always, you can please contact us, either of us or anybody at CED, at the information you see on your screen right now. But with that, Russell, can you take it away?
Hi, everyone. Glad to see you here today. Let's move on to the first slide then. Next slide.
Yeah, we're going.
Okay, whoop, too far. Back it up. There we are. So this is a very busy slide. Over on the left-hand side, you'll see a couple of fire scenes that have been attributed to the lithium-ion batteries. Near the top center, you see photographs of money, because lithium-ion batteries are big money. The market's just gone leaps and bounds. And it's amazing how it's changing so many different things about how everybody does business. To the right are some popular things that people might be using lithium-ion batteries in, including automobiles, tools that almost everybody that does any handiwork around the house has a battery-powered tool or two. They have the top right is a little red car as a radio remote control car. We all have our cell phones. And I'm not aware of any cell phones that are not using lithium-ion technology. And then there's the drones and the hoverboards. In the lower right, it talks about how Rolls-Royce and hybrid cars and how they're using lithium-ion batteries. And in the center bottom, you see a pair of scissors cutting an extension cord going over to a lead-acid battery, like a typical car battery. That's because lithium-ion batteries and their technologies have completely changed what's going on. And the lead-acid batteries are still strong in their niche, but they don't have what they used to have as far as market share of battery usage. Next slide, please. So now lithium-ion batteries, it's the lithium ions that are doing the migration. So if you look at these two pictures, the one on the left, one on the right, you'll see the red is for voltage, and the lithium ion is in the green dot with a little Li in the plus. So on the left-hand side, the battery charging shows the migration path of the lithium ion as it goes from one side of the cell to the other. On the right-hand side, the battery charging shows the migration of the lithium ions during the discharge process. And it's just kind of neat to know that the lithium ions are going back and forth, back and forth, back and forth every time you do a battery charge or discharge using your batteries. Next slide. This one, we have the red slash on purpose because it's kind of like a circle in the no, like say no to this or say no to that. There have been a lot of recalls on lithium-ion battery products through in the last few years. Electric scooters, they're kind of in the middle, 500,000 on those alone. The other charging systems and laptop computers, it all adds up to lots of recalls. Next slide, please. The reason we're having recalls is because people believe something's not safe about them. But we're not talking about the products as much as we are talking about the lithium batteries that are in the products. Are lithium batteries safe? And it's not so much a matter of safe or not safe as a matter of is it safe and how to make it safe, or being safer is what we're trying to target, and that's what the industry is trying to work on. If we think back to gasoline, diesel, propane, natural gas, and lead acid batteries, there was a time in their infancy when those products were coming out that they weren't as safe as they are today. So we say, okay, what does it take to be safe? Well, any energy technology can be safe when their use is designed properly and used as designed. And that's a mouthful. It's got to be designed properly and it's got to be used as designed. Next slide, please. So what is it that tears up batteries? A common running theme for things that damaged electrical equipment is heat. Heat kills. So the heat and typical battery failure causes are the loose connections, overcharging, overdischarge, and dendritic growth. But heat is what kills, and each of these things points toward the heat. Next slide, please. So the batteries, they start with the manufacturing process, making sure they have the pure components in what they do. And the early rash of lithium-ion battery failures were attributed to manufacturing process failures. They've corrected those failures for the most part. You can still buy bad batteries, but not like you used to. So if we assume that lithium-ion batteries can now be purchased that are relatively safe, what's the next step? Well, that falls into the battery management system, or BMS. They're huge. And what the battery management system does is monitor the voltage, current, and temperature, because the voltage and current are precursors to the temperature excursions that can hit. Next slide, please. So when you look at your typical 18650 battery, you look in the top left, you'll see some of the parts on there that I've labeled. So the PTC is the positive temperature coefficient, so that it can vent if it needs to. And the CID is the current interrupting device. All batteries do not have these. All lithium-ion batteries are not created equal. If you're getting a real deal and buying lithium-ion batteries on the internet, beware. 18650, when I first started doing these battery investigations, I thought it was very impressive and interesting that the name for the 18650 battery came from the physical dimensions of the battery. So if you look at the top right, you'll see that it's the scale there shows 18, and then on the bottom scale you see 65. So if you drop the decimal points, it's 18650. That's where the name for the batteries came from.
So right there, you have a little insight into some of the things that amuse electrical engineers.
Those of you in the audience, you may or may not be amused by them either. If you look at the bottom right-hand corner, that's a battery as opposed to a cell. The other pictures on this page, like the green battery, is actually a cell. When it's used, it determines whether or not a single cell is the battery or it's multiple cells in a pack together make a battery. And I refer to the bottom right as a battery pack. And the battery management system is on the face of it facing us. And that's kind of it. Next slide, please. So when a single cell is used as a battery, it can still have a battery management system. So in this case, you're seeing the clip ring was the red, being able to use to hold on the battery management system, which is the green disc on the lower left-hand side, and then the insulating caps on either side of it. So it is possible for a modest additional fee to get a lithium-ion battery that has its own battery management system integral to the battery itself. Next slide. But most lithium-ion batteries do not have their own battery management system. They rely on something else. So on the left-hand side, you see that printed circuit board. That is monitoring the health of 4 cells. And on the right-hand side, you see where those cells are and their voltages. And you have a main controller and a power interface, so that anytime the main controller thinks that something isn't right, it can turn off the whole battery pack. And that can be infuriating especially if there's no diagnostics telling you why it stopped.
Russell, what sort of equipment would you see this size of a pack in?
That's a good question. This cell pack is too small to be like a tool pack for a portable drill or something like that. It might be used for a drone or a small remote control car. Next slide, when you're ready. Okay, so the United States Consumer Product Safety Commission had these two pictures on their website that I snagged. Now on the left-hand side, you see the images that are not a photograph, but more like a CT image, CT scanned image. And you see the white dots. And those are little outliers, like why would they have white dots in the middle? And say, what is that telling us? You look on the right-hand side, and these same batteries have been through a fire. If you look closely at the top right, you can see where the cap of the battery on the right has lifted up and has vented. And you kind of wonder why. Now, it looks like the jelly roll is still inside of it. And you may see some mechanical damage center on the right photograph, but it's inconclusive. You're not really sure what you might see. So that's why you do the CT analysis. That's why you might even take it apart, and you might open up the jelly roll inside of it to see what you see on the inside. Next slide. So this is what can be. So this wasn't from an 18650. This is from a larger lithium-ion cell pack. But all three of these images come from the same battery and are the same piece of copper tissue, just at different resolutions or different focus. I mentioned before about the dendrites, so that when you discharge or charge, I'm reading at the top of the screen here, when you discharge or charge beyond a specification, the copper ions and the lithium ions can stick and plate onto the anode, and that plating and that stickiness are called dendrites. And it prevents the proper transfer of lithium ions during charging and discharging of the battery. It can also cause physical damage to the separation between the anode and cathode, and that damage can short out between the anode and cathode, and that's what we're looking here in these images. So you imagine a single sheet of the copper foil on the left-hand side with the black magic marker on it, circling just above the where the scale is on it. Look to the right-hand side, and it looks interesting. There's a lot of holes there. So now we zoom in a little bit further, and these are not different colored holes exactly. These all have the same light backdrop of a white LED light shining through the copper foil. And where you see the white light, the copper foil integrity is completely gone. It's a hole. Where you see the red lights, that's where the copper sheet integrity is almost gone, but not quite. And it's so thin now from the damage that's been caused that it's you can see light through it. Whereas a regular copper sheet, you wouldn't be able to see light through it at all. And these are believed to have been caused by the dendrites perforating through the separation layer and shorting out between the copper and aluminum foils and causing a lot of massive overheating, because when the aluminum and copper short out to each other, it's like a spark. It's sort of a self-correcting problem because it sparks, clears itself, and then moves on. But you get enough shorts inside, and then you cause a fire, or you cause enough heat to cause the fire. And this is the sheet that was believed to have been a contributing factor for this fire. Next slide, please.
Thanks, Russell. I mean, that slide right there kind of makes my eyes glaze over a little bit. So let's see if we can talk about some specific products that you've worked on and maybe a couple of issues with each one.
Okay, yeah, that star field was kind of interesting. My first lithium-ion case was for e-cigarettes. I'm a non-smoker, so I was never impressed by e-cigarettes, even though a lot of smokers were. They thought they could smoke them in hospitals because it didn't have tobacco in it, but it does. It has the tar nicotine in it. But what you're looking at there may or may not have any battery management system in it. But my first battery fire for e-cigarettes was a mech mod. Those of you in the audience, there's probably at least a couple of y'all that are smokers or have family that are smokers. You may not know what a mech mod is, though. Mod meaning modification, mechanical meaning mechanical. So what they've done is pretty much taken out any battery management system or any safeties out the e-cigarette and are directly shorting out the battery to the coil that's in the head of it that's vaporizing the oil into the cloud. You see the guy exhaling. I found out through doing my research and going to some of these vape stores that it's a huge status symbol for these people that use, not everyone, but among those that use, to get a huge cloud of puff of smoke. Think back to the old black and white movie days where people would be smoking on a pipe, they take a leisurely drag and then have a big cloud exhaling it. Well, if I look on YouTube for people smoking using these cigarettes and mech mods, it's amazing the amount of smoke that people draw into their lungs and then exhale vigorously in a way that they and their peers find to be very impressive. The challenge is that when these batteries are shorted out that way, it changes their discharge rate. All lithium-ion batteries are given a charging rate and a discharge rate typically designated with the letter C. And when you exceed the charging specifications, then you're creating these dendrites, which means you're likely to charge or discharge the battery too quickly, changing the chemical makeup, shorting out the internal plates, and causing a fire. We've had these things explode in people's mouths. At least one fatality that I've been involved with. Mostly there are other burns and things where people drop them in their pockets because they thought, oh, okay, I'm not using it, so I'll drop it in my pocket. But the heat had a cumulative effect, caused a fire, put their pants on fire, and put them in the hospital. Next slide.
Let's go back to the future for the next slide.
The hoverboards. I love the hoverboards. I think they're a great concept and a really neat thing. I like them better than skateboards. And yet, boy, did they take a beating in the market because they're associated with causing fires. And the few cases that I've had on hoverboards weren't fires that started when they were being used, but fires when they were being charged. Manufacturers of all the lithium-ion batteries seem to have a common thread of charging under supervision. Not to just stick it in a closet somewhere and charge it. And yet, the fires that I've investigated are purported to have been when the batteries are being charged and these things. I don't know if you even buy hoverboards anymore. It's a shame because I think it's a neat product. I see people have a lot of fun with them. And maybe if they were just charged properly and people use the original batteries or quality batteries that had a quality battery management system, maybe they'll make a comeback. Next slide. Okay, this was my second lithium-ion battery fire. Now this car wasn't the one that was involved, but for that case is still open, but for conversation purposes, it was very, very much like this. So here we see a 4-cell pack on the bottom left. And earlier, Pete asked me what kind of battery management system that might be used in and the battery pack. So here we have it, a small remote controlled car. So the small remote controlled car has its own control systems controlling the servos from the remote control, but it's also got the battery management system, keeping track of the battery health. The challenge with these packs are that in the case that I am involved in, the battery pack swelled to the point that it would no longer come out of the car easy. So the teenager that was in possession of it charged it in place, which was contrary to the manufacturer's recommendations and guidance of removing it. So imagine that when these dendrites start forming and it starts causing problems, swelling takes place. And that swelling is a tell. And it's not that much different than really old cans that are way past expired of pork and beans or green beans or any other canned product when you have the swelling and because the cans popped or exposed. Or if you have other products that the integrity, it doesn't look right because the packaging is now swollen. Same thing for these lithium-ion cells. If you see any distortion or of the shape on the outside of it, dispose of the lithium-ion batteries properly, because if you don't, you run the risk of having to pay the consequences later. Next slide.
This next slide has me a little nervous because we use these on almost all of our investigations these days. They're a wonderful tool, but you can tell us how dangerous drones can be.
Right. Several of these drone fires as well. Again, the drones that I've investigated haven't caught fire when in use, but only when they were being charged. And when the battery pack wasn't removed, they were charged inside the drone itself. Or one of the cases, it had the battery pack removed and they were charging it, but it was left unattended while the person left the home, and they came back to their house on fire and seeing fire trucks pulled up to it. Drones are amazing. And without the lithium-ion battery technology, if you were trying to use lead-acid batteries, drone technology would not be here. Next slide.
And I think we're all seeing a lot of these, and we're not seeing them on the golf course. We see them just about everywhere.
Right. Now, I call this a golf cart, but it hurts the feelings of the people that manufacture them because they call it a golf car. For those in the audience, I chose to use the TART symbol just because, I mean, the word cart, because that's what most of us are familiar with. They used to all use lead acid batteries, but now there's people out there that are retrofitting them with lithium-ion battery packs. And they're doing some things like increasing the voltage. So whatever voltage they had on the lead acid batteries, these owners found out if they boost the voltage just a little bit faster, they'll be able to outrace the next guy when they head to the 19th hole for a cold drink. It's just amazing what these guys, it's like sailboats racing each other. Unless you're a sailboat guy, you don't understand. Why are sailboats racing? They're so slow. It's like, no, it's real racing. You get a golf cart, who's going to race golf carts? Well, golf cart owners and drivers do. I've had several golf car fires. The one that's coming to mind that those foils I showed you came from ended up being circumvented by the upgrade person who put in too high of a voltage for the use of the car, did not use a battery management system properly designed for the lithium-ion batteries. But even that system turned off the batteries. The guy coached the owner of the golf cart to how to be able to circumvent the safeties to be able to get it home. The guy took it home, put it on the charger, and walked away from it, and it burned his house down. He was in the home, but there were no fatalities in that case. He charged it unattended. He defeated the few safeties that were there because the guy that did the upgrade system apparently told him how to do it. And the lithium battery packs did not have the properly designed battery management system. Again, it starts with the design and application, and then if it's used properly. And I think those are the highlights of some cases that we wanted to share.
Thank you, Russell.
We're looking at our time, Pete. I know our time's 12:22 now.
Yeah, I think that, again, I would like to be very respectful of everybody's time. You have Russell's contact information. If you have any specific questions, please feel free to give him a call at any time. We'd love to talk with you. And have a great Friday and have a great weekend, everybody.
Bye, everyone. Thanks for joining us. And those that join afterwards that download from the website or take a look at the website. Sorry you couldn't join us live, but glad you're here now. Goodbye.